Hello everyone, welcome to this tutorial on getting started with Node.js. In today's digital world, Node.js has emerged as a powerful tool for building fast and scalable network applications. From web servers to real-time chat applications, Node.js has transformed the landscape of server-side development. In this tutorial, we'll go step by step, right from installing Node to writing Node modules, and you will get a good foundation of writing Node apps. We'll dive into what exactly Node.js is, its building blocks, and talk about how its architecture enables developers to build high-performance applications. Next, we will install Node. Then we will see how we can manage and switch Node.js versions using NVM. After that, we'll talk about some IDE options. We will be installing VSCode, which I will be using for this tutorial. Then, we will jump into writing and executing code using Node. Next, we'll dive into what Node modules are and create some local modules. We'll understand the mechanism by which one module can consume variables and methods from another one. We'll next look at some useful core modules Node provides and demonstrate them using in our code. We will understand the global object in Node. Event handling is a central and important feature of Node. We will take a look at the events module to understand the event handling in Node and write event emitters and handlers. We'll talk about callback functions, promises, and async await keywords in Node, which are the fundamental ways to write asynchronous code. Finally, we'll talk about Node Package Manager, which allows us to share our Node modules as well as pull third-party Node modules to extend our code. We'll install several modules as well as also understand the version semantics. So by the end of this tutorial, you would have a good solid idea of Node, its tooling, and basic constructs which will set you up to writing Node programs efficiently. Also, if you're familiar with a certain section, then you can move on to the next one. I will include bookmarks in the description below. So let's get started. Let's start talking about what Node is. Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. What makes Node.js unique is its ability to execute JavaScript code on the server side, allowing developers to use the same language for both client-side and server-side development. This unification streamlines the development process and fosters code reusability across different layers of the application. Now, let's take a closer look at the architecture of Node.js. At its core, Node.js consists of several key components. The first is the V8 engine. Node.js leverages Google's V8 JavaScript engine to execute JavaScript code, the same engine used behind the Chrome browser. Ryan Dehel, who created Node, took the V8 engine and wrapped it with some other functions and created Node.js, which allows us to write JavaScript in our server-side code, and the V8 engine compiles JavaScript code into machine code, making it highly efficient and performant. Node.js relies on libuv, an asynchronous open-source I/O library for handling asynchronous operations. libuv provides an event loop that allows Node.js to perform non-blocking I/O operations, making it ideal for handling large number of concurrent requests. Node.js bindings act as a bridge between JavaScript and the C++ libraries, enabling developers to access low-level system resources like the operating system and file system that are not natively supported by JavaScript. Node.js comes with a set of core modules that provide essential functionality for building applications. These modules include HTTP for creating web servers, FS for file system operations, and events for handling events. Talking about events, one of the key features of Node.js is its event-driven architecture. If you're familiar with other server-side technologies, Node handles web requests differently than others. One approach many of these server-side technologies use is multi-process approach, where there is a pool of processes and each request is handled by a process. Code running in one process is isolated and is not aware of the code in another process, and the number of requests we can serve simultaneously is limited to the number of processes in our pool. Another way is multi-threaded approach, where a process can have multiple threads and each incoming request is handled by a thread. In this case, since the threads are a part of a single process, even though code is isolated to the thread, they are aware of the other concurrent threads, especially when accessing shared memory space. Again, the number of concurrent requests is limited to the number of threads in the process. Node works on a single-threaded event loop model. There is a single thread in a single process which handles all incoming requests. So I/O operations like request to access a file, an incoming HTTP request, etc. trigger events. The event loop receives the event and hands it off to the underlying I/O operation. In Node.js, most of the I/O operations are non-blocking and asynchronous, meaning that the application does not wait for I/O operations to complete before moving on to the next task. An analogy you would often hear to understand is of a restaurant. In a restaurant, a waiter receives the order from a customer and gives it back to the cook, and while the cook is preparing the order, goes to the next customer for his or her order and gives it to the cook. And when the order is complete, the cook notifies the waiter, who then delivers the order to customer A and customer B. This is asynchronous. If the waiter had waited for the cook to finish the order before going to the next customer, that would be synchronous operation, and as you can imagine, would slow down the operations and we'll have a lot of unhappy customers. There are callback functions which you write, which are notified when the event has been processed or complete. So these are special types of functions which are passed as arguments to the main function. When the main function execution completes, the callback function is called. For example, when the file read activity is complete. This approach allows Node.js to make asynchronous calls and handle multiple requests simultaneously without blocking the execution thread, resulting in a better performance and scalability. Using this model, there is no shared memory as it is a single thread, and Node will service one callback function at a time. So if there are multiple incoming HTTP requests, it can only handle the callback function one at a time. So it's our responsibility as developers to spend as little time in the callback function so that Node doesn't have to spend too much time in there and we can service more requests more efficiently. So this brings up the point as to where Node.js should not be used. It should not be used for CPU intensive operations as its async model depends on its thread being released pretty quickly after getting the instruction to go on to the next instruction. But if your instruction requires it to do a lot of work which would take time, then it would not be suitable. Alright, now with this overall understanding of Node, let's talk about getting Node on your machine. Hello everyone. Now let's see how to get Node.js on your machine. One way is to go to the Node website. Let me Google it. Go to the download section and get the version for your OS. There is a Windows installer, Mac OS installer, and Linux binaries. You can also get them as Docker images. There is a long-term support version and a current version. The current version has latest features, but I typically would go with the LTS version. Apart from downloading it from the Node website, some other ways are on a Mac platform using the homebrew, so typing in the command brew install node. On Windows, the chocolatey, so choco install node.js.install. And on Linux, I prefer using nvm, which I will show you in the next clip. I am on a Mac now, so let me show you how to install it on a Mac using the download. However, the process is fairly simple for other platforms too, where you download and follow the instructions of the installer. Let me click on the Mac OS binary, which downloads this package. Let me double click it, and it starts the Node installer. It is a very intuitive process. Just follow the prompts and the installation should be complete. To check if Node has been installed properly, let me open up a terminal session, type Node, and we should see Node with its version number. This would mean that Node is properly installed on your machine and you are good to go. As I was saying, that the version of Node changes very fast, and sometimes we need to switch between different versions of Node for different projects. Let me now talk about NVM or Node Version Manager, which makes it extremely easy to manage Node versions. Node versions change very fast, And Node Version Manager or NVM makes it very easy for us to move versions up or down or get a specific version. Let's take a look at this. Let's Google NVM. Click this link to go to the GitHub page for NVM. Let me scroll down to the installing and updating section. You can run the install script manually. You can get the script following this link or use the curl or wget command to get it. I should however mention that NVM is only for Linux and Mac OS, not for Windows. For Windows, you can run it using WSL, Windows Subsystem for Linux, or there are some other options too to run them like NVM Windows, Nodist, or the one I like, NVS. Let's click this link to go to the release page for NVS on GitHub. It has an installer and works very smoothly just like the NVM for Linux. Alright, let's get back to the NVM install section. Let me copy the curl command. I'm on a Mac OS and here is a terminal session open. Let me paste the command here and run it. It installs successfully. Let's type NVM and it opens up the help for NVM with instructions on how to use NVM to install Node and its specific versions. Typing nvm install --lts, this will install the long-term version of Node, which is currently 20.11.1. You can get a specific version. Say let's type nvm install 21. This will install the latest 21 version of Node. I had previously installed it, so it is using the already downloaded version. If you do not have it, it will download and install it for you. Running node -version, we can see now that we are on Node version 21.6. I can switch to version 20 by typing node use 20. I had installed it earlier, so it's available, and NVM switches our Node environment to 20, which we can verify by typing node -version. If you want to use NVM 18 for an earlier project and it's not there, it'll tell us so and give us a command to get it. Let's type nvm install 18. It installs it and also switches our version to 18. Let's confirm it. nvm use 21 will switch us to version 21, again which we can confirm using node -version. So it's a very handy utility to manage and switch between Node versions, and I highly recommend it. For Windows, NVS utility, which we saw earlier, works the same way. Before we start writing code in Node, let's talk about the different Node IDEs as they make writing code very easy and efficient. Using an IDE makes it very easy to develop Node projects. There are several options out there like IntelliJ IDEA, Visual Studio Code, Brackets, Atom, Sublime Text, Cloud9, a browser-based IDE, Eclipse, etc., and the list goes on. You can use any one of these you like. However, I like Visual Studio Code. There is no free version or professional version for this. It is absolutely free for everyone, and it's very powerful. I'm on a Mac now. I will install it here, but installing it on other operating systems is equally easy. So let's Google Visual Studio Code and go to the download link. Here we have installers for Windows, Linux-based systems, and Mac. The installs are very simple. For Windows, it's an exe. You can also download it as a zip system installer. For Linux, you have the Debian package or RPM. I'm on a Mac, so let me click on this link for Mac. The download is complete. Let me click the downloaded zip file. It is unzipping it. In the unzip, I see the application. Let me double click it and it opens up Visual Studio Code. It's as simple as this. On my Mac, I generally like to keep my applications together, so let me drag it to the applications node, and now I can easily search for it and get it from my applications on the Mac. Okay, it's time now to start writing some code, so let's get to it. Alright, let's get into the exciting stuff, writing code. First, let me create a new folder for our application, call it My App. Now, in Visual Studio Code, click Open Folder and point it to the My App folder. Click on New File name it app.js. Now, as I had mentioned earlier, Node allows us to write JavaScript code server-side outside the browser, so any JavaScript code can be executed by Node. Let me create a function hello which takes in a name parameter, and inside the function, using console.log, I print hello, and using the plus sign, concatenate it with name. And then simply invoke this function hello, passing in a parameter, here my name Pankaj. I like to autosave the code, so if you like that, you can go to the file menu and check autosave. To run it, let me from Visual Studio Code click on terminal and then new terminal. It opens up a terminal window at the bottom. Notice it is in the root folder of our app, my app. Now to execute our code, simply type node app.js. You can omit the .js extension as Node would expect a JavaScript file. Press enter, and we should see Node execute our JavaScript code and prints hello Pankaj. Cool. I also wanted to introduce you to the Node command line or RPEL programming environment. REPL stands for Read, Evaluate, Print Loop. This is a very handy way to run Node commands and see the results on the command line. So in the terminal window, when I type node, it opens up the REPL session. So let me run a command. Math is a core module dot square root, passing in 2. We see the result. So REPL reads the command, evaluates it, prints it, and then loops or waits for us to enter the next command. I can run JavaScript line as let x equal to 2. It will evaluate it, and since there is nothing to print, it comes back as undefined. But if we type x, it knows the value of x which we had set in the earlier command, evaluates it, prints 2, and loops to wait for the next command. It is intelligent and knows when to allow multi-line commands. So let me type a function sum which takes in a, b. Now notice when I press enter, it knows that it is not over yet, and with 3 dots indicates I can continue. Let me type return a plus b. Enter. Now enter the closing braces, press enter, and now it knows the function definition is over, and it returns us back to the REPL prompt with undefined as there is nothing to return. We can run sum 1, 2, and it returns back 3 and waits for the next command. Now if you want to know more about a command, say what are the methods available with the math module, after the dot, if you press tab twice, it tells you all the available functions. Let me choose floor 5.2 and it returns 5. To exit the REPL session, you simply type .exit and press enter. Alright, with this overview about writing and executing Node.js code, let's now talk about Node modules. Node.js modules are the essential building blocks in a Node.js application, allowing developers to organize and encapsulate code for better maintainability and reusability. These modules enable developers to break down their code or application into smaller manageable units, each serving a specific functionality. By leveraging the module system in Node, developers can make two modules talk to each other, easily import and export functions, objects, or classes from one module to another, creating a modular and scalable approach to software development. We will understand it better with examples. Node.js includes 3 types of modules: local modules, core modules, and third-party modules. Local modules are modules created by yourself and stored locally. You can import them using the relative path. Core modules are included with Node.js and do not require installation. You can import them directly using the required command. Third-party modules are modules downloaded from package managers like npm. They are stored in the Node modules folder. We'll talk about all of these. Let's first start with the local modules. So in the last clip, we created our file app.js. That is a local module. Let me create another file logger.js. Put in the console.log statement in here, and this logger.js is another local module. So every JavaScript file in Node is a module. But that sounds pretty simplistic and frankly unimpressive. Well, Node behind the scenes does a lot. It wraps each file in the wrapper function and invokes it, and this structure makes it very flexible and powerful. Let me show the wrapper function behind the scenes which Node creates. So let's create a function log which takes in the message and inside does a console.log of the message. Let's also do a console.log of the arguments, which are the arguments of this function. Let's call this function passing in a test message module test. Let me go to the terminal and run node logger. And here we see the arguments to this function which start with 0. This one has only 1 and its value is module test. Okay, let me get rid of this code and just put in a line console.log arguments. What do you think will happen here? Let me run it. And as you can see, behind the scenes, Node has wrapped it up in the wrapper function, which has 5 arguments. Let me put the code back in. So this is how Node will wrap it up in a function with the first argument as an exports object, which currently is empty. The second one is the require object, which we will learn about shortly. The third one is the module object. You can see its structure. The ID, path, the exports parameter is actually the alias of the module.exports property and its other properties. The fourth argument is the file name of the current file with its entire path, and the fifth one is the current directory. Let me remove this console.log and output the __ dir name and file name and run it. And here we see the info. Let me remove the outputs. Using the let keyword, let me create a variable level which indicates the log level and assign it a value informational. Now this function log and this variable level and all the parameters of the wrapper function are local to this module. And the other module, for instance the app.js, cannot see it. Let me get rid of the code here. If we want the app.js to use the log function and the level variable, we have to export them, meaning making them public for other modules by assigning them to the exports object. Remember, exports is an object which points to the module.exports property. So let's say module.exports.level equal to level and module.exports, and we can have a different name for the consumers who see them than the internal name, so logger, which points to the log function. So our exports object now has 2 attributes to it, level and logger. Going back to the app.js, the way we bring in the logger module is by using the require keyword. So constant log require, and we refer to the module using its relative path, so /logger. If it was in a subfolder, we would have it included here. If in the parent, we would have it go one level up by using .. So let's bring the logger module. So what comes here is what we have put in the exports object. So the exports object is the top level API, which we store it here in the constant log inside our app.js module. Let's examine it by using the console.log, passing in the constant log. Run node app, and we see that it's an object with 2 attributes, level with the value of informational and the logger, which is a function log. Cool. Now we can use these inside. So let's first output the current value of the level, assign the log.level to error, output it again using console.log, and using the log.logger function, invoke the log function of the logger module, passing in logging message using logger. Let me clear the screen and then run node app. We see the previous value of level as informational, the changed value as error, and the output using logger.js log function. So this is how, using the exports object and the required keyword, we can have modules talk to each other and use the other variables, functions, etc. Now, the exports object is an alias of the module.exports. So we could remove the module keyword here, run node app, and we see the same results. Let me not export the level variable. In app.js, remove lines referring to it. Run node app again, and we see the output message again. Now since exports is an alias to the modules.exports, which is an object, as long as we are exporting an object, we can use it. But if you change the exports object to be a function, this would error, as we are changing the structure of an underlying object using an alias. Let me run node app to show it. And we see the error that log.logger is not a function. If we are changing the structure of the exports object, like here to be a function, we have to directly work with the module.exports object. So assigning this the log function, so now it is a function. In app.js, now what is returned is a function, not an object. We have to use it directly. So log is a function. Let me clear the screen, run it, and it works as before. The module.exports is very flexible. I can change it to be an array. Running node app now outputs the array. I can change it to be a string. And now it outputs the string. So it's very important to remember that if you're changing the type of the module.exports from an object to another type, then you cannot work with the exports alias, but you will have to work with the module.exports object directly. Let me change it back to the function. Now running it, we can verify that what's being returned by the export is a function. Also, using constant is a good idea. I could have used var here, and it still runs fine. But then, there is nothing stopping for someone to change its value later, say 1. And now, running it gives 1. But if we had kept it as a constant, that would have prevented someone from doing it, and would have received an error assignment to a constant variable. Alright, now let's talk about some core modules which come with Node. Core modules are built into the Node.js runtime and can be accessed by requiring them in your code. Node.js provides a number of core modules that can be used to perform various tasks. Some examples of core modules in Node.js include the HTTP module, which allows us to build web applications, interact with APIs, and has methods for us to create HTTP servers and clients, handle HTTP requests and responses, and make HTTP requests to other servers. The FS module provides an API for interacting with the file system, allowing you to read and write files, create and delete directories, and performing various other I/O operations. The OS module allows us to interact with the operating system and do things like get system information, environment variables, and process management, which the Java code running in the browser cannot do. Here, I am on the Node.js website. Go to docs, and you can see a list of modules and objects built in Node. The buffer module, events, HTTP, OS, path, and a few other modules. These core modules are an essential part of the Node.js ecosystem and are used in a wide range of applications, from simple command line tools to complex web applications. To know the available APIs or methods in the module, click on it. For example, here the OS module, and we can see there are functions here to get the free memory, home directory, hostname, etc. The file system module has a class FileHandle. A class is an encapsulation for attributes and methods, like here the close, read functions, etc. You will see how to work with classes in Node. You can further click on a function to get more details about it. Alright, enough talk. Let's go to code and see some of these in action. Let's first see how to work with the OS module. Let me remove this console output. We get the OS module again using require OS. Notice here there is no path mentioned, as it is a built-in module. Now when we do OS, we see a bunch of methods. Let's call os.freemem with parentheses. Parentheses are needed to execute a function. Get it in the data variable. Now let's do a console.log of data. Let me run the Node app, and we see the free memory on my machine. We can get the CPU information by calling CPU function. Let's run it, and here we see the CPU info on my machine. Cool. Let me clear my screen. Next, let's see how to work with the file system module. Again, we get it by calling require fs. Now again, fs dot shows a bunch of methods at our disposal, and as you can see, there are both synchronous and asynchronous versions of almost all methods. For example, append file and its synchronous counterpart, append file sync. Let's first call read file sync, a synchronous method for reading files. Let me pass in our built-in local parameter passed in the wrapper function __ file name. Let's save it in a constant content. Now let's do a console log of it. Let me create a visual separator before the content. Output the content, which by default will be in byte stream, and let me convert it to a readable string by calling toString method. Let's run it, and here we can see our file content. Let's see how to run its asynchronous counterpart. Let me comment these lines first. Constant content equal to file.read, passing in two parameters, the first being our file name parameter, and the second is called a callback function, which will be called once the OS completes the asynchronous operation of reading the file. It takes in two parameters, the first being the error object, which stores the error info if there are any encountered, and the second one is the data object. We can call it anything. Let me call it fcontent. Open and close the braces for the function. Inside we check if error is not null, then we output it to the console, else if we output the file content is and then the content. Let me clear the screen. Run node app, and we see the content as before, just that it's now being executed by the asynchronous function. What happens when there is an error? Let me change the file name to something which does not exist. Clear the screen and run it again. And here we see the error object with message no such file or directory. So these are just a couple of popular code modules. I would encourage you to go to the Node.js website to read and try the other core modules. We saw the file name, module, exports, etc. are local variables, and we can, using the exports object, make them public. But is there a way to make a variable or object global in Node.js? Let's talk about it next. In the browser, we are all very familiar with the window object, which is a global object. However, in Node.js, it's not there. So running this console.log for the window will report that it's not defined. However, there is an object global, which is a global object. Running a console.log for global, we can see that it has methods like clear immediate, set interval, set timeout, etc. Now we can create global objects and variables of our own. So for instance, I can say global.myvar equal to 2. We can access it in the module, so let's run it, and we can see its value. Now we have not exported it, but if we cut this console.output line and paste it in app.js, let me comment this other console output and run it, we can access the global.myvar variable over here too. So this is how easy it is to create global variables and objects. But creating global variables or objects of our own is not a recommended practice, as global variables of our own can lead to concurrency issues, memory occupation, and scope problems and conflicts. They should be left alone for Node.js to use internally. Node works on an event model. Let's next take a look at this very important and powerful concept and study the core event module in Node.js. The event module in Node.js is a core module that provides an event-driven architecture for handling events and implementing the observer pattern. It allows developers to create, emit, and listen for events within their applications. This module plays a crucial role in building scalable and modular applications by enabling communication between different parts of the code base through event-driven programming. So here I am on the Node.js website, and we can see its core events module here. The events module at its core has the event emitter class, using which developers can define custom events and attach listeners to respond to these events asynchronously. It has several methods, but a couple of them are widely used. Let's take a look at this. Let me get rid of the existing code here. Let's define a constant event emitter. Notice the camel case with the first letter capital when working with classes. Using require brings in the events module. Since event emitter is a class, let's create a new instance from it event emitter as new event emitter. For those who are not familiar with classes, a class is like a template. For instance, a cookie cutter, using which you can create multiple individual cookies or instances of cookies. Each cookie inherits the basic characteristics from the cookie cutter class, but can have its own specific things. For instance, we can have a chocolate chip cookie or an oatmeal cookie, but both of them inherit or have common properties of a cookie, at the same time having their own flavor. Now, examining the event emitter instance, we see it has several methods, but the one most widely used is emit, using which we can define our own event, say send email, and the second argument being the data here, a string hello. It can be any object. Now this event becomes a part of the node event loop, but emitting the event doesn't do us much good unless we have a listener or handler for this event. And you can create that by using event emitter dot add listener or its equivalent on method, which takes the first argument as the name of the event we want to handle, so send email, and the second argument is the callback function, which takes in an argument, you can name it anything, say arg, which represents the data passed in the emit method. Inside the method, let's say console.log, sending email with details, and concatenate the argument. So this callback function will be called once the event is finished. Let me run it. So node app. We do not see anything. What happened? So the order here is wrong. The listener has to be registered first before the event is emitted. So let me move the code up, and now the emitter. Run it again, and now we see the message. So the order is important. Another thing is that you can have multiple listeners for the same event, each doing its own thing. So that adds a lot of modularity and power to the node event management. Now typically for sending email, you would need an email address to send to. Now when there are more than one parameters, it's better to have an object with key value pair. So let me wrap this in an object with a key 2 for the email and message for the message. Running it again, we see the entire object being passed through in the argument. Now, in later versions of JavaScript, they have simplified the function syntax, so we need not have the function keyword, but the argument or arguments, and then using this arrow, pass it to the body. These are called inline functions. And of course, the result is the same. Now typically, you would have a separate class with events and emitters in an application. Let me create a new file, helper.js. Copy the code to bring in the events class. Paste it here. Okay, now for the event emitter, let's create a function sendEmail, which takes in the arg argument. Inside, let's put event emitter.emit with the sendEmail event, taking in arg as the argument. Using module.exports.sendEmail, let's export the sendEmail function. Now inside app.js, let's bring the helper module top level API using require ./helper. Now we do not need to emit the event here, but rather use the helper module to do that. So change it to helper.sendEmail, passing in the object. We do not need this line anymore. Let me put a console.log in the helper module function to let us know it was invoked. Now let's run node app.js. We see the console output indicating helper.sendEmail function was called. However, we do not see the console.log from the listener. That is because this event emitter is not the same as this event emitter, the one which emitted the message. These are two different instances, so the instance which emits it could be the only one which can listen for it. So let me take this code from here and paste it here before the emit event. Now, here this event emitter is an instance of the event emitter class in helper.js, and so it should be able to receive the event. Going back to app.js now, we do not need the module import, and the code becomes very simple as everything is handled by the helper module. Let's run app.js again, and this time we see its output from the listener. Cool. Now as I was mentioning earlier, we would generally keep our events and emitters as a separate class, which other modules in our application can use. So let me convert this in a class which will encapsulate the functionality. So class helper, open close braces. Let me copy the send email function inside here. Now inside the class, we do not need the function keyword for our methods. We can make this helper class extend the base event emitter class so it will inherit its methods to emit and register listeners. So with this change, we do not need an instance of event emitter. And inside, instead of the event emitter instance, we can say this to refer to the event emitter of this helper class. Similarly for emitting it. Now, instead of exporting the function, we can have the top level API export be the helper class. Now back in the app.js module, the export from the helper module is a class. So using the convention, we have the first letter capital. Next, since the class is a template and we need an actual object or instance to work with, let's create one with const helper equal to new helper. This helper instance has our send email method and it has the add listener emit methods also, as helper inherits from the event emitter class. Now we will call helper.sendEmail. Let's run it as node app.js and we see the same results. Now we can add further events. For example, let's say we want to create a method for sending text. So we create a method send text. Let me copy the send email method and modify it. So the event will be send text. Let's change it in the event emitter too. Change here sending text with details. Finally change the method name to send text. Now in app.js, we can see our second method helper.sendText and pass in an object with a number and the text message. Let's run it and we now see both the email and text in here. So this is how we can add multiple events and listeners. Now we have seen the callback function, but with the later versions of Node, there is a better and cleaner way to handle asynchronous methods. Let's take a look at that next. Async await in Node.js is a powerful feature that allows you to write asynchronous code in a synchronous manner. As we have more nested callback functions, it helps avoid callback hell and makes asynchronous code more maintainable and easier to understand. As we know, Node.js works in an asynchronous manner. So here we have the read file operation using the fs module, and then there is this callback function which will be called when the read operation completes, and it will log a message to the console with the file content. And after that we have a message to the console demo. Now when we run it, we see the demo message first before the file content, as the asynchronous nature will hand off the read operation to the OS and move on to print the demo message first, and when the read operation completes, the callback function is called, printing the file content. Async await makes it easier to handle promises and write asynchronous code. A promise in JavaScript, particularly in Node.js, represents the eventual completion or failure of an asynchronous operation and its resulting value. Promises and callback functions are similar in that both allow to handle asynchronous operations. But using promises makes the code more structured, decoupled, and easy to read. So here in this example, we have the read file function which has a callback as we saw earlier. And here is another example of doing the same thing using promises. Using the util module, we promisify read file call. Now the read file function does not need a callback function, but would rather return a promise. We use the await keyword. The await keyword will pause the execution until the promise returns. Then the console output will be called. We include the async keyword to the function, so async await go in pairs. Let's take a look at it in a demo. Let me create a new file demo async.js. Let's bring in the fs modules export. We will read a file. So let me create a file first, call it test.txt, and let's just enter say test in here. Okay, so let's read this file. Let me do fs.read file test.txt. There is no path since it is in the same folder. And here is the callback function. Inside we output the data. Let me run it. Now by default we will get the output as a buffer of bytes. We can enter an optional second parameter indicating the encoding here UTF-8 to read it as text. Run it, and now we see the text test. Next, say once we read the file, we want to write it to another file. So inside the callback function, we call fs.writeFile, give the file name test2.text, the data to write, encoding UTF-8, the error parameter, and then inside let's write file created. Let's run node demo async, and we see the output file created. If you want to do another operation after this, then we will have to have another level of nesting, and as you can see, the code is getting difficult to read and maintain. A better way is to use async await. Let me comment this code. First, let's bring the export of the util module. Let me do constant read file, and util module has a function promisify, which will convert the fs.read file to return a promise. Now, let me write a function access file inside which I will do const data equal to read file. I will put the async keyword to the function and using await, wait for the promise, and then call the access file function. Let me run it. Oh, I forgot to output the data. Run it again, and cool, I see the data here. Now to catch any errors, let me surround it by a try catch. Catch takes the error parameter, and we can log the error. Let me change the file name to test3.text, which does not exist. Run it. The error is caught and displayed. No such file or directory. Put it back to test.text. Clear the console. Now, to write the file, we will similarly declare a const write file, which is util.promisify, which takes in fs.write file. And now, using await, call the write file function, writing to test2.text, and then say file created. So using await, we will pause for the promise of the read file to return, and then the second await waits for the promise of the write file operation before outputting file created. So you can see there is no more nesting, and the code is so much more easier to read. The function to handle when the operation returns is decoupled from the main call. Let me run it, and we see the result. I also wanted to show you the template writing with string interpolation instead of concatenation, which is a more modern approach. So let me pass to this function a file variable to read, change it to file here. Now using console.log, this is how we have seen so far how to concatenate. So data in plus for concatenation plus file is plus data. Now since the function expects a file name, let's pass the file name over here. So test.text. Let me run our module. Oh, I forgot to put the .log here. Let me clear the screen, put the .log, run it, and now we see the results. A better way to write this console.log using the new way is, now using console.log, I start with the tick symbol, the one above the tab on my keyboard, and to put the file variable, I do a $, open bracket, file variable, close bracket, and then the rest of the line. Again, data is a variable, so $data within parentheses, and then the end tick. Let me comment the previous line, run it, and we see the same output. This template writing has better readability than concatenation. Cool. Now, no discussion of Node is over until we understand the Node Package Manager or NPM. Let's take a look at it next. NPM or Node Package Manager is the default package manager for the JavaScript run environment Node.js. It provides a registry of packages that can be installed and managed in the project, and so it makes it easy to pull in dependencies. With NPM, developers can version control and publish their own packages for others to use. So it makes it very easy to share as well as consume work done by others. Here, let me Google NPM and it brings the link to NPM home. If you click on pricing, it is free for public package authors. You can sign up here. I'm signed in my account here. It shows me the popular packages like Lodash, which is a utility package. React is popular. There is Express for website development, Movement, which allows to work with dates in JavaScript, etc. You can search for a dependency here, for example, ESLint, which is used for static code analysis. Let's search for Express now. Let me click on this. And here it shows further details like how to use it, install it, version, license information, etc. Let's take a look at it now in VS Code. npm comes with Node.js install, and there is no need for a separate install. So in the terminal, if I type npm, it shows the usage tips, version, etc. Let me clear the screen. Now on the left is VS Code and on the right is my folder. The first thing you would do in your project is use command npm init. It will ask you a bunch of questions about your project like the name, version, description. Let me type my first app. I will just hit enter and accept the defaults. And now you can see it created a file package.json. Okay, let me open the package.json file and it shows the information it prompted us for like name, version, etc. The package.json file is a JSON file that contains metadata and configuration information about a Node.js project or package, including its dependencies, scripts, and other properties. Now if you run npm -init -yes, it will just take the defaults and not prompt you. Now we can install a dependency like Express by typing npm install, or I for short, Express, hit enter, and it installs Express. You can see now our package.json file has a dependencies section with Express and its version. I will explain the semantics of the version number in just a bit. If you notice, it has also created a node modules folder here, and if I expand it, it shows a bunch of folders, bringing in not only Express but also the packages it depends upon. For example, Express depends on the accept package, so it brings it here, and inside the accept is its own package.json, which lists the dependencies on which the accept package depends upon along with their versions. So just one npm install command brings in all the dependencies and subdependencies along with their right versions according to the package.json files. Let me go to the package.json file. So when in our code we ask for an installed package, Node will look in the node modules folder. Let me install another one, npm I -save, which is optional and will do the same as above to add -to the dependencies section. Let's run npm install ESLint -save dev, or we can also use -D. Notice it created a new section here called dev dependencies, which would only be used during development and are not needed when the code is deployed to production. Now these packages would be available only to our project, but there are some utilities like nodemon which watches our folders for a change and automatically restarts Node for the server to make the changes. This is a useful utility while developing projects, and I might want to have it globally instead of installing it for every project. I can do this by calling npm I nodemon-g for global. It installed successfully. To verify, I can type npm ls-g to browse all installed global packages on my machine, and I see nodemon here. npm ls gives me all packages for my project. We can uninstall a package by saying npm uninstall -, which will remove it. And we can remove a global package by calling npm uninstall nodemon-g. And now it is removed as verified by running npm ls-g. Now package-log.json keeps a version of all the dependencies and subdependencies, so it makes it easy to pull them down, say if I'm sharing it with my teammate or creating another app based on this. Let me create another folder for a second app. Copy over just the package and package-log.json to it. Now let's go to File, Open Folder, and open up our second app. Open up a terminal. Run npm I or install. This command will look at the two JSON files in our folder and bring down all the dependencies and subdependencies with the right versions. And here we see the node modules folder created with all the packages. So this is how package.json and package-log.json helps someone get the project dependencies on their machine. Next, let's take a look at the semantics behind versions. So as you saw, the format of npm version is like 4.18.3 in this example. 3 here indicates patch level change. So an update to the patch level, for example 4.18.4, would be a bug fix. 18 is a minor level change. So this will be updated when, say, there is a functionality change or a new functionality is added. However, the code would be backward compatible and we do not have to make any changes to our code. 4 would be a major level change, which is a breaking change, which would require us to change our code. Now the caret sign here means that only the patch or minor version updates are allowed, but not the major version. So here a version number greater than 4.18.3 would be okay, but it has to be less than 5.0.0. So 4.18.4 would be okay, 4.20.0 be okay, but not 5.0.0. The tilde sign indicates only patch level updates are allowed. So here, anything above 6.0.3 is okay as long as it is less than 6.1.0. So for example, 6.0.4, 6.0.7 are okay, but not 6.1.0. Greater than or greater than equal to sign indicates versions greater than or greater than equal to are okay respectively. So here for greater than 6.0.3, 6.1.0 is okay, 7.0.0 is okay, but not 6.0.2. Greater than equal would mean the same except 6.0.3 is also okay. And the reverse is true for lesser than or lesser than equal sign. So here 6.0.1 is okay, 5.9.0 is also okay, but not 6.0.4. Less than equal to 6.0.3 would, along with the less than rule, also allow version 6.0.3. The dash or hyphen sign indicates the version range, which is okay. So here 6.5.0 would be okay, but not 6.11.0. Latest would mean the latest version. So hopefully now when you see these version semantics, it will make more sense. With this, we have come to an end of this tutorial. I enjoyed making this and I hope we got a good foundation and a good start towards your journey writing Node.js code. I wish you all the best. Thank you for watching.